Hi students, this is AJ sir. Let's study 10th standard ICSE math, exercise 22C, heights and distances, part 3. Exercise 22C, cancel question 1, 3, 4. Let's start with the fifth question. Mark it as IMP. The radius of a circle is 15 centimeters and the chord AB subtends an angle of 131 degree at the center. So we have to calculate the length of the chord and the distance of the chord from the center, the perpendicular distance. This is the diagram. AB is the chord. The central angle is 131 degrees. That is the angle subtended by the chord at the center of the circle. Angle ACB is given as 131 degrees. And the radius is 15 centimeters. That is AC is equal to BC is equal to 15 centimeters. Construction, we'll draw CD perpendicular to AB. Now in triangle ACB, we notice that AC and BC are equal, radii of the same circle, so that becomes an isosceles triangle. In an isosceles triangle, if I know one angle, then using the angle sum property, I can find the other angles. So we'll find angle A. Since I've specified the name of the triangle ACB, hence I can use a single letter to denote angle A, which is same as angle CAB. This comes out to be 24.5 degrees. So now I have a right triangle CDA with an angle A. It's important to have a right triangle and the value of one angle to use trigonometrical ratios. Now we'll find CD as well as AD because we know the hypotenuse CA value as 15. I'm going to find Roman number 2 CD first, that is the length CD. It's the perpendicular distance of the chord AB from center C. If you notice, CD is the opposite side to the angle and hypotenuse is given. So which ratio correlates the opposite side to the hypotenuse? Sine. So we'll have to use sine in this triangle. In right triangle CAD, sine 24.5 is equal to CD upon CA. Sine 24.5 can be found out from the trigonometric table. So 0.5 is here and 24 is out here. So this is the answer, 0.4147. Substitute that value and CA is given as 15. Cross multiply and we get the value of CD as 6.22 centimeters. So the distance of AB from the center is 6.22 centimeters. Next, we have to find AB, that is the length of the chord. That is Roman number 1. First we'll find AD and then we will be able to find AB. AD is an adjacent side, so we'll have to use cos. Here, cos 24.5. Again, that can be found directly from the trigonometric table. That's AD upon CA, cross multiply, and we get the answer as 13.65 centimeters. Now, DB is equal to AD. That's because in circles, there is a property that whenever we draw perpendicular to the chord from the center of the circle, it bisects the chord. That's a property in circles. You will study that in chapter circles. So D is the midpoint of AB. You can even prove this by congruency of triangles, proving these two triangles congruent. But we'll directly use the property. That means AB is double of AD and the final answer comes up to 27.3 centimeters. Next, the seventh sum. It's an IMP sum. Here we have a vertical tower. Obviously, we won't have a horizontal tower. And then we have a vertical flag staff on top of it. And they have certain angles of elevations given as alpha and beta respectively. We have to prove that the height of the tower is this fraction. So how do I prove it? This is the diagram. Let AB be the tower. So the height of the tower is x. And let CA be the flagstaff on top of the tower. So that's h. The tower has an angle of elevation alpha, and the flagstaff, top of the flagstaff, has an angle of elevation beta from the same point. First, we'll use trigonometry in triangle ADB. You will use tan here. Tan alpha is AB upon DB. So you get the value of DB. Notice that in the big triangle, DB is common. So even there, we'll find the value of DB. You see, tan of beta is CB upon DB, and CB is H plus X. So we got two values of DB. That was the strategy used here. No numbers are given. So the only way to find some relationship is find something common between both the triangles, the smaller one and the bigger one. And the only thing common is DB side. So find the value of DB and then equalize them. From 1 and 2, we get this is equal to this. And then it's simple algebra. You cross multiply, open the brackets, get the like terms together, that is x and x, remove x common. And I want x alone, so this goes in the denominator. This is the required expression, because they wanted us the height of the tower, that is x, in terms of tan alpha and tan beta as per the question. Next, cancel question 9 and even 11 and 12 because they are of the same types of sums we have done in the previous exercises. Let's do the 13th sum. We have a vertical pole and a vertical tower, and the angle of elevation of the top of the tower from the foot of the pole is 60, and the angle of elevation of the top of the pole from the foot of the tower is 30. So the diagram is like this. The pole is 20 meters high, and the angle of elevation of the top of the pole from the foot of the tower is 30, and the angle of elevation of the top of the tower from the foot of the pole is 60. We have to find the height of the tower and even the horizontal distance between them. So let PQ be the pole and TS be the tower. First, in triangle PQS, we'll use tan 30. That's opposite upon adjacent, PQ upon QS. PQ value we already know, that's 20, and tan 30 is 1 upon root 3, so we can find QS. That is the distance between the pole and the tower. That's what we'll find first. So we should mention here Roman number 2. We could have written it in the beginning as well. The answer is 34.64 meters because it was 20 into root 3. Next, in this triangle TQS, use tan 60, TS upon QS. Tan 60 is root 3, and QS value we found out to be 20 root 3. Use that one. Don't use 34.64. If you use 20 root 3, it becomes easy to calculate because when it goes up here, root 3 into root 3 is 3, and then you get the answer for height of the tower 60 meters. That's Roman number 1. Next, the 15th sum. Mark it as IMP. From a point 36 meters above the surface of a lake, the angle of elevation of a bird is 30 and the angle of depression of its image is 60. So this is the diagram. You are at point P at a height 36 meters from the lake. QA is the surface of the lake. So there's water underneath it. So if you wish, you can draw some waves. There are no waves underwater, but these curved lines means there is water underneath. This is the lake. The bird is at point B. Let it be at a height of h from the surface of the lake. So BA is h. So the reflection of the bird B is at R. So AR would be equal to AB, H and H. So let me write that here. AR is equal to BA. Reason? Well, that's a law of physics, right? If this is the mirror and if the object is h meters away, the image will be h meters behind. The angle of elevation of the bird from point P is 30 degrees and the angle of depression of the image from the same point is 60 degrees. Now we know that PQAC is a rectangle, so PQ is 36, that means CA is also 36. So BC will be BA minus CA, which is H minus 36. We need it for triangle BPC. And for triangle PCR, we require CR. What's that? Well, AR is H and CA is 36. So totally CR is H plus 36. Now we shall start using trigonometry. So first write all the data and even this. Now in right triangle PBC, we'll use tan 30, which is BC upon PC. Substitute the values, cross multiply and get the value of PC. Notice that even in the big triangle, PC is the common side. So that's how we know what's the strategy to use. So in this right triangle PRC, use tan 60, substitute the values, cross multiply and get the value of PC. So we got two values of PC, which is the common side between the two triangles. Equalize them, cross multiply, open the brackets and get the value of H, 72. So the height of the bird from the sea level, don't just write height of the bird. A bird can't be 72 meters high. From the sea level, it is 72 meters. Next, cancel 16, 17, 19, 20, 21. If you wish to do them, you may. Let's do the 18 sum. It's an easy sum, but what may be confusing are the angles of depression mentioned here, 30 and 60. So we'll draw the usual diagram here, like this. These are the angles of elevation, which are alternate angles to the angles of depression. So AB is a building and DC is a lamp post. The angle of depression from the top of the building to the top of the lamp post is 30 degrees, and from the top of the building to the bottom of the lamp post is 60 degrees. So now it becomes easy to solve. The height of the building AB is given as 60. This is a rectangle, so definitely XB is equal to DC and XD is equal to BC, opposite sides of rectangle. In right triangle ABC, we use tan 60 and we find the value of BC. That comes out to be 34.68 meters. So the distance between the building and the lamppost is 34.68 meters. Notice here we have no choice but to divide by 1.732. If you want a shorter route, then convert the tan 60 as 1 upon tan 30 and then get the value of tan 30 from the trigonometric table in decimal. So that will go up and multiplication is easier with decimals. But if you are going to use tan 30 as 1 upon root 3, then again the root 3 will go up and you will be left with dividing with a decimal number. Next, Roman number 2. In right triangle AXD now, AXD, we know the value of XD because that is same as BC. But you don't use the decimal value of BC, use 60 upon root 3 value. So XD is 60 upon root 3, tan 30 is 1 upon root 3. This goes up, get AX alone, which comes out to be 20 meters. If you would have used a decimal value, then you would have got a decimal answer like 20.01 or something, which would have been acceptable as well, but that wastes your time. But the sum is not done yet. We need to find the height of the lamp post, that is DC. Now DC is equal to XB and XB is equal to AB minus AX. So do AB minus AX, that's 60 minus 20, and the answer is 40 meters. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.